Okay, section 9-3, operations with complex numbers. This will be the first part of 9-3, and we will cover the second part of 9-3, de Moivre's theorem, in a separate video. In this section, we're going to learn to multiply and divide complex numbers. We did that in section 1 when we had our complex numbers in standard form, but now we have our complex numbers in trig form also, and we need to figure out how to multiply those. So we said that trig form of a complex like this, r times cosine theta plus I sine theta. And if I wanted to multiply two of those together, we would call this r1 and theta 1. And I'm going to multiply it times r2 times cosine theta 2 plus I sine theta 2. That's kind of messy, but I think you get the point. So here's what it looks like after a whole lot of going through formulas and stuff. It ends up like this. R1 times R2 times the cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. And that's how we multiply them together. That's in your book, or you can write it down real fast. And then we're going to learn to divide, which is just this same number divided by this number. And our formula for that looks like this. R1 divided by R2 multiplied times cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Now please note, this is the correct formula for dividing the trig form of complex numbers. In your book on page 183, it is written incorrectly. They have a plus sign in between the original problem and this formula. It's not added together, so it needs to look like this. So go in your book, scratch that out, make a correction. Don't follow what's in the book right now. Okay, so let's find the product of a couple of trig functions. If I have the trig function 6 times the cosine of 30 degrees plus I sine 30 degrees times one half cosine 120 degrees plus I sine 120 degrees. How am I going to do that? Well, I'm going to multiply my r values first. So I have 6 times 1/2 times the cosine of theta 1, which is 30, plus theta 2, which is 120, plus I sine theta 1 plus theta 2. So 6 times 1/2 is 3. Cosine of 30 plus 120 is 150 degrees. And the cosine of 150 degrees is negative square root of 3 over 2 plus I. The sine of 150 degrees is 1/2. And if I distribute my 3, I have 3 times negative square root of 3 over 2 plus 3I over 2. And there's nothing else I can do, except that just looks messy. So this is my standard form, a plus bi. I could put this I out in front if I wanted to give it, the appearance more of the standard form, but this is acceptable. So that's the standard form of that problem. Let's try another one. What about this problem? This looks a little more like what we started with in this chapter. Negative 4i times negative 3 minus 5i. Well, we're going to use the FOIL method to multiply that out, and that's going to give us 3 plus 5i minus 12i is minus 7i minus 20i squared, and we know that I squared is really worth negative 1. So that becomes negative 20 times negative 1, which becomes positive 20. And I can add these real numbers together. That's 23 plus negative 7i. Standard form. Now, in the last section when we were graphing, we said that 23 would be our a value plus negative 7 squared. 23 squared is 529. Negative 7 squared is 49. So r equals the square root of 578. And we said tangent of theta equals b over a, which is negative 7 over 23. So theta would equal negative 16.92. Well, this does not exist on our circle, our coordinate plane, or our complex plane. A negative number doesn't exist. So we're going to add 360, or a negative, not negative number, but a negative angle. We're going to add 360 degrees to this so that theta equals 343.08 degrees. So if we were to put this back in trig form, which is square root of 578 times cosine of 343 degrees plus I sine 343 degrees. So now we've taken that standard form that we started with up here, and we've turned it into a trig form. Let's look at this one. This is number 7 in your homework. We have negative 3 plus 3i. It's a standard form of a complex number divided by square root of 8 times cosine of 45 plus I sine 45. So what I have here is a standard form down here and a trig form here. I need to convert this to a trig form like we just did in the last problem. So I need to find my r. So r squared equals a squared plus b squared, or r squared equals negative 3 squared plus 3 squared. R squared equals 9 plus 9. So r equals the square root of 18, or 3 square root of 2. And our theta for this function, tangent theta equals b over a, and that's 3 over negative 3 which is negative 1 over 1. So theta equals negative 45 degrees. Again, we don't want that. We're in quadrant 2, so we're going to add 180 degrees to that, and that gives us 135 degrees on our plane, our coordinate plane. So the trig form of the first number is going to look like this. R is 3 square root of 2 times cosine of 135 degrees excuse me, plus I sine of 135 degrees. And now we can divide this with the other trig form of complex number we were given to begin with. So I'm just going to put that down here. And I'm going to change the square root of 8 to something similar to this. I can change the square root of 8 to 2 square root of 2. That's going to help us a little bit. And we have cosine of 45 degrees plus I sine of 45 degrees. Well, the first number in our division, our formula for dividing these is R1 divided by R2. Well, 3 square root of 2 over 2 square root of 2 leaves us with just 3 halves. And we have cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2 cosine of 90 plus I sine 90. And what is the cosine of 90? It's 0. And the sine of 90 is 1. So if I multiply 3 halves times 0, I get 0. And if I multiply 3 halves times 1i, I get 3 halves I. So this is our standard form.